All right, find the equation of the plane passing through the point 1, negative 1, 1. It contains the line of intersection of the planes x plus y minus z equals 2 and 2x minus y plus 3z equals 1. So first let's just get the equation for the line of intersection of those two planes. So we've got x plus y minus z equals 2 and 2x minus y plus 3z equals 1. So I'm going to set these both equal to y and then set them equal to each other. So y equals 2 plus z minus x, and then y equals 2x plus 3z minus 1. Set those equal to each other. I get 2 plus z minus x equals 2x plus 3z minus 1. So now I'm going to solve for x just because it seems like the easiest variable to solve for. So I get negative 3x when I subtract this 2x over equals 2z. So I'm subtracting this z over here. And minus 3. So I'm subtracting this 2 over to here. And then x equals negative 2/3 z plus 1. Obviously divided by the negative 3 turns that into a negative over 3. So divide negative 3 by negative 3 and you get 1. So next what I'm going to do is I am going to take this value right here that I just solved for x, and I'm going to plug that into this equation so that I can get the value of y in relation to the other variables. So I'm going to get y equals z minus x plus 2, but x is negative 2/3 z plus 1. So I'm going to get y equals equals z minus negative 2/3 z plus 1. Make sure that's right, yeah. Plus 2. And then when you solve all that, you get y equals 5/3 z plus 1. So now we've got our value of x, we've got our value of y, and we know that z obviously is equal to z. So what we're going to do now is we're going to write our symmetric equations, or yeah, that's what it's called, symmetric equations. So we're just going to set z equal to t. And since we know that z is equal to t, that means that y equals 5/3 t plus 1, and x equals negative 2/3 t plus 1. So all these are our symmetric equations. If we want to put that in parametric form, we're going to get RT equals the point 1, 1, 0, because this is going to be 1 in our x, 1 in our y, and 0 in our z, plus t times the vector, our coefficients to our t values, so it's going to be negative 2/3 in the x, 5/3 in the y, and then just 1 in the z. Now from this, we got a vector out of it and we have a point. So right now what we're going to do first is use that point. So we're going to call that P. It's going to be 1, 1, 0. And we're going to call the point that we started with, that they gave us up here, negative 1, 1. We're going to call that Q. So Q equals 1, negative 1, 1. And we're going to make a vector from that. We're going to call that PQ. And that is going to be head minus tail, so 1 minus 1 is going to be 0, negative 1 minus 1, negative 2, and then 1 minus 0 is 1. So I'm going to have to make some more space for this. Flip the page. Alright, so our vector again, I'll write that out again. So PQ equals 0, negative 2, 1. And the vector that we got from our parametric equation, we're going to call that V. That is going to be negative 2/3, 5/3, and 1. And again, that's just from the equation that we had right here. This one. So this is V, and then this was P, and then we got PQ from that. So back over here, we need to get a normal vector, and to get that, we're just going to cross those. So PQ cross V equals I, J, K, and there's 0, -2, 1, -2/3, 5/3, 1, and then we cross those, we get -2 minus 5/3 in the I direction, obviously, so -2 times 1 minus 1 times 5/3, 2 minus 5/3, minus, because it's going to be the j vector next, 0 minus 1 times -2/3, so 0 plus 2/3 in the j direction. Run out of room. Put this one down here. Plus our k vector, which is just going to be 0 times 5/3, which is 0, minus -2 times 2/3, which is positive 4/3. So we're going to get 0 minus 4/3 in the k direction. When you solve that out, I'm going to write it out like with these things instead. I don't really like the letters. We're going to get -11/3 as our x value, -2/3 as our y value, and -4/3 as our z value. And that's equal to the vector a, b, c. That's going to be really important. And then we can use either one of the points that we found, like either p or q. I'm going to use q just because it was given. And that point is 1, -1, 1. And this right here is going to be our x naught, our y naught. This is going to be our z naught. And then we're going to plug that into the formula for a plane, which is going to be a x minus x naught plus b y minus y naught plus c z minus z naught equals 0. And then plugging in our values, since all these are divided by 3, I'm just going to multiply this whole thing times 1/3. So I'm going to get 1/3 a, since we took out that 1/3, is just going to be -11. So -11 times x minus our x naught, which is 1, x minus 1, plus, or I guess it's going to be minus because it's a negative. So -2, it's plus b, b is negative though, 2 y plus 1 minus a -1, minus 4, our z value, times z minus 1 equals 0. And that is going to be the formula for our plane.